So hello everyone, in this audio class we will discuss the 20 most important questions from the chapter Spatial Information Technology. These questions will be very much important for your upcoming KVS, NVS Geography, PGT interview. So let's get started with the question number 1. What do you understand by Spatial Information Technology? So Spatial Information Technology is an integrated technology used to collect, store, retrieve, analyze, manage and display geographically referenced information. It combines geographical information system or global positioning system or GPS, remote sensing and digital cartography and database management system. It supports scientific planning and decision making by integrating spatial and attribute data. For example, while selecting a suitable location for a new hospital, GIS integrates information on population, connectivity and land use to identify the most appropriate site. Next question, you mentioned spatial information. What is spatial data? So spatial data refers to the information that has a definite geographic location on the earth surface. It is represented by coordinates and displayed as points, lines or polygon on a map. Spatial data answers the question where. For example, the location of a river, road or school, forest on a map represents spatial data. Next question, then what is attribute data? How is it different from a spatial data? So attribute data describes the characteristics or properties of a spatial features. It answers the question what, while spatial data answers where. Both are essential for GIS analysis because location allows it not sufficient without descriptive information. For example, a school's location is spatial data, whereas the number of students, teachers and classrooms represents the attribute data. Next question, why is GIS considered the core component of spatial information technology? So GIS is considered the core component because it integrates spatial and attribute data, performs analysis, prepares thematic maps and supports scientific decision making. It transforms raw geographical data into meaningful information for planning and management. For example, during flood management, GIS combines rainfall, elevation and drainage data to identify flood prone areas. Next question, what are the major components of GIS? So GIS consists of hardware, software, data, people and procedures. Hardware processes the data. Software performs analysis, data provides the information. People operate the system and procedures ensure systematic functioning. All 5 components work together to produce reliable geographic information. For example, in urban planning, computers, that is hardware, GIS software, satellite data, trained planners and standard procedures together prepare a urban development plan. Next question, what is the raster data and in which situations is raster data preferred? So raster data is a cell-based data model in which the earth surface is represented by a grid of pixels. Each pixel contains a value representing a specific geographic phenomenon. It is most suitable for representing continuous features such as temperature, rainfall, elevation and satellite imagery. For example, sorry, just wait for a while. Okay, so for example, a satellite image showing vegetation cover is stored as raster data because vegetation changes continuously over space. Next question, what is vector data and why is it important in geography? So vector data represents geographic features using points, lines and polygons. It is suitable for discrete features with clearly defined boundaries and provides high positional accuracy. Points represents location, lines represents linear features and polygons represent areas. For example, schools are represented as points, roads as lines and district boundaries as polygons. Next question, compare raster and vector data. Which one would you prefer for land use mapping? So raster data stores information in the form of pixels and it is suitable for continuous phenomena, whereas vector data stores information as points, lines and polygons and is suitable for discrete features. For land use mapping, vector the data is generally preferred because land use classes have well defined boundaries and can be edited and analyzed more accurately. For example, agricultural fields, urban areas, forest boundaries are efficiently mapped using vector data. Next question, what is remote sensing and how is it related to GIS? So remote sensing is the science of acquiring information about the Earth's surface without direct physical contact using sensors mounted on satellites or aircrafts. GIS and remote sensing are complementary technologies. Remote sensing provides up-to-date spatial data while GIS stores, analyzes and presents that information for decision making. For example, satellite images acquired through remote sensing are analyzed in GIS to prepare flood hazard maps. Next question, explain the relationship among GIS, GPS and remote sensing. So GIS, GPS and remote sensing are the three major components of spatial information technology. GPS determines the precise location of an object. Remote sensing collects spatial information from satellites or aircrafts, and GIS integrates, stores, analyze and displays the collected information. Together they provide an efficient system for spatial analysis and planning. For example, during disaster management, GPS identifies field locations. Remote sensing provides satellite images of the affected areas, and GIS integrates all the information to prepare relief and rehabilitation maps. So the next question is, explain the basic principle of remote sensing. So the basic principle of remote sensing is based on interaction between the electromagnetic radiation and the Earth's surface. Every object reflects or emits electromagnetic energy in a unique way. Sensors record this energy and the recorded data are processed to identify and analyze different surface features. For example, healthy vegetation reflects more near infrared radiation than dry vegetation, allowing satellite images to distinguish between them. Next question, what are the essential components of a remote sensing system? So a remote sensing system consists of energy source, atmosphere, target object, sensor, platforms, data transmission, data processing and interpretation. These components work together to collect and analyze information about the Earth's surface without direct contact. For example, in satellite-based crop monitoring, the sun acts as the energy source, crops are the target, and the satellite sensors record the reflected energy. Next question, differentiate between active and passive remote sensing. So in passive remote sensing, the sensor depends on the natural energy, mainly sunlight, reflected from the Earth's surface. In active remote sensing, the sensor itself emits electromagnetic energy and records the reflected signal. Passive systems are commonly used for land cover mappings, where active systems can operate both day and night and even under cloudy conditions. For example, optical satellite imagery is a passive remote sensing whereas radar is an example of active remote sensing. Next question, why is electromagnetic radiation or EMR important in remote sensing? So electromagnetic radiation is the medium through which information is transferred from the Earth's surface to the sensor. Different surface materials absorb, reflect and emit EMR differently. This unique spectral behavior helps in identifying various land features. For example, water bodies absorb most of the incoming radiation and therefore appear dark in satellite images, where barren land reflects more energy and appears brighter. Next question, what are the major applications of remote sensing in geography? So remote sensing is widely used in land use and land cover mapping, agriculture, forestry, water resource management, urban planning, disaster management, environmental monitoring and mineral exploration. It provides updated spatial information quickly and accurately over large areas. For example, during floods, satellite images are used to identify inundated areas and support rescue and rehabilitation planning. So the next question is, what is GPS? Explain its working principle. So GPS, or global positioning system, is a satellite based navigation system that determines the precise location of any object on the earth's surface. It works by receiving signals from at least four satellites. The GPS receiver calculates the position using the travel time of these signals, a method known as trilateration. For example, GPS is used in mobile phones to determine the exact location of a user. Next question, what are the three segments of GPS? So GPS consists of three segments: space segment, satellites orbiting the earth; control segment, ground stations that monitor and control the satellites; and user segment, GPS receiver used by the people. These three segments work together to provide accurate positioning, navigation and timing information. For example, while using Google Maps, mobile phone acts as the user segment and receives signals from GPS satellites. Next question, differentiate between GIS, GPS and remote sensing. So GIS is used to store, analyze and display spatial data. GPS is used to determine the exact geographic location of an object, and remote sensing is used to collect information about Earth's surface without direct contact through satellite or airborne sensors. These three technologies complement one another and together form the foundation of spatial information technology. Example, in flood management, remote sensing provides satellite images, GPS identifies field locations, and GIS analyzes the affected areas to prepare flood maps. Next question, discuss the major applications of spatial information technology in India. So spatial information technology is widely used in agriculture, urban planning, disaster management, forest management, water resource management, environmental monitoring and transportation planning. In India, organizations such as ISRO and NRSC extensively use GIS, GPS and remote sensing for resource mapping and disaster monitoring. For example, ISRO's Bhuvan Geoportal provides satellite-based geospatial information for planning and development. Next question, why has spatial information technology become indispensable in modern geography? So spatial information technology has become indispensable because it enables accurate data collection, efficient storage, spatial analysis and scientific decision making. It helps geographers understand spatial patterns, monitor environmental changes and prepare sustainable development plans. With the availability of high resolution satellite data and GIS tools, spatial analysis has become faster, more reliable and evidence based. For example, during cyclone forecasting and disaster response, GIS, GPS and remote sensing are integrated to assess damage, plan rescue operations and support rehabilitation. So spatial information technology is an integrated geospatial technology that combines GIS, GPS, remote sensing, digital cartography and database management system. It facilitates the collection, storage, analysis and presentation of geographically referenced information. Today, it plays a vital role in resource management, environmental monitoring, disaster management, urban planning and sustainable development. making it one of the most significant tools in modern geography. So the next question is, what is digital cartography? So digital cartography is the process of creating, editing, storing and displaying maps using computer technology. It produces accurate, easily updatable and interactive digital maps. For example, Google Maps. Next question, what is georeferencing? So georeferencing is the process of assigning real world geographic coordinates, latitudes or longitudes, to a map or image so that it matches its correct location on the Earth's surface. For example, georeferencing a scanned topographical map before GIS analysis. Next question, what is geocoding? So geocoding is the process of converting a place name or address into geographic coordinates into latitude or longitude. For example, converting Kolkata airport into its exact geographic location. Next question, what is topology in GIS? So topology is the set of rules that defines the spatial relationships among geographic features such as connectivity, adjacency and containment. For example, a road network where all roads are properly connected are at intersections. Next question, what is digital elevation model? So digital elevation model is a digital representation of the Earth's surface elevation used to analyze terrain characteristics such as slopes, aspect and watershed. For example, flood and watershed mapping. So the next question, what is normalized difference vegetation index or NDVI? So NDVI or normalized difference vegetation index is a satellite derived index used to measure the health and density of vegetation based on the reflection of red and near infrared light. For example, monitoring crop health. Next question, what are LISS and PAN data? So LISS or linear imaging self scanner provides multispectral images with moderate spatial resolution for land use and vegetation studies, and PAN or panchromatic provides high resolution black and white images for detailed mapping. For example, LISS for crop mapping and PAN or PAN for urban mapping. Next question, what is the difference between IRS and landslide satellites? So IRS was developed by ISRO in India and Landsat was developed by NASA and in USA, and IRS mainly used for Indian resource management and Landsat used for global earth observation. And IRS includes LISS and PAN sensors, and Landsat includes OLI TIRS sensors. Next question, what is the Bhuvan geoportal? So Bhuvan is India's national geoportal developed by ISRO, providing satellite imagery, thematic maps and geospatial services for planning, resource management and disaster monitoring. For example, monitoring flood affected areas. And the next question, this is the last question for today, how can spatial information technology support sustainable development goals? So spatial information technology supports sustainable development goals by providing accurate spatial information for sustainable planning, disaster risk reduction, environmental conservation, resource management and smart urban development. For example, GIS based planning for sustainable land use and water resource management. So thanks for listening. Keep listening for further audio classes. Thank you.